Have you ever wondered why the house always wins in a casino, or how insurance companies decide how much to charge you? The answer isn't magic. It's a powerful mathematical concept called expected value. At its core, expected value is the long-term average outcome of a random process if you were to repeat it many, many times. It is the center of gravity for probability. To understand this, let's look at the basic definition. In probability theory, the expected value of a random variable x is the weighted average of all possible values that x can take. We denote it as E of x. Think of it as a balance point on a seesaw, where the weights are the probabilities of each outcome occurring. If you flip a fair coin and win $1 for heads but lose $1 for tails, the expected value is exactly 0. The mathematical formula looks like this. E of x equals the sum of each outcome xi multiplied by its probability p of xi. It's a simple multiplication and addition process. For a discrete variable, we use the sigma notation. While the formula might look intimidating at first, it's really just a way of saying multiply what you could get by the chances of getting it and added it all up. Let's look at a practical everyday example, a simple dice game. Imagine a friend offers you a deal. You roll a standard 6-sided die. If you roll a 6, you win $30. If you roll anything else, you lose $6. Should you play? Let's calculate the expected value. There is a 1 in 6 chance to win $30 and a 5 in 6 chance to lose $6. Multiplying these gives 5 and -5. Adding them together gives 0. In the long run, you won't gain or lose anything. This is a fair game. Now, let's step into the world of professional gambling, like the roulette wheel in a casino. A standard American roulette wheel has numbers 1 through 36, plus a 0 and a double 0. That's 38 slots in total. If you bet $1 on a single number and win, you get $35 back plus your original dollar. However, your chance of winning is only 1 out of 38. When we run the math, the expected value of a $1 bet is negative $0.0526. This means for every dollar spent, the casino expects to keep about 5 cents. This is the house edge. Expected value is also the backbone of the global insurance industry, a market valued over $5 trillion. When an insurance company insures your car, they calculate the probability of an accident. If there's a 1% chance of a $10,000 claim in a year, the expected cost for the company is $100. To stay in business and cover administrative costs, they must charge you more than that, say $150. You pay for the peace of mind, and they profit from the law of large numbers. Beyond games and finance, expected value helps us make better life decisions. Should you take a risky job offer with a high bonus but low stability, or a stable job with a fixed salary? By assigning personal values to outcomes and estimating their probabilities, you can calculate which path offers the highest expected utility. It turns out that the most successful people in business, like Warren Buffett, often think in terms of probabilities and expected returns rather than certainties. In summary, expected value is the bridge between the uncertainty of a single event and the predictability of the long run. It reminds us that while we can't control a single roll of the dice, we can understand the math behind the patterns. Whether you are investing in the stock market, choosing an insurance plan, or just playing a board game, always ask yourself, what is the expected value? It's the closest thing we have to a crystal ball in a world of randomness. References: John E. Fround, Mathematical Statistics; J. L. DeVore, Probability and Statistics for Engineering and the Sciences; Damodar Gujarati, Basic Economics.